Hi and I welcome you to this video. Here I am going to talk about hash code function in Java strings. I will start by explaining you about the use of hash code in hashing a string, and then I will explain you one of the use cases of hash code function. Followed by that, I will explain what is happening under the hood when we call hash code function over a string. Without delaying further, now let's jump into our discussion. Hash code is useful for converting or reducing a string into a number, and this process of reducing a string to a numerical value is called hashing. Actually, hash code function does not restrict itself to convert only string to a numerical value. In fact, it can convert any object to a numerical value, but mostly hash code is used to convert a string to numerical value. One of the most important and useful behavior of hash code function is that it will return a consistent numerical value on multiple invocations. I mean, hash code function will return the same numerical value when you call hash code function for a string multiple times. Now you might have a question, why we need to reduce a string to a consistent numerical value in first place? The answer is, hash code function has one of the most important use cases even within hash-based data structure in Java. Hash code function helps to store and retrieve data from hash map used by hash-based data structures in Java. Now let's see this with an example. Consider we want to store employee details in a hash map. As you always know, here we will be storing data as key-value pairs in hash map, where each key is mapped to a value. In this example, employee name will be the key and employee details will be the value. When you try to store a key and value in hash map, internally hash code will be used to reduce the key into a numerical value, and this numerical value will be used as index to store the value in hash map. When we try to retrieve the data from hash map by using a key, internally the key will be reduced to numerical value by invoking hash code function. I hope you remember that hash code function will return the same numerical value on multiple invocation of a string. As I mentioned, hash code will be returning the same numerical value which we used while saving the value to hash map. Since we can directly access the value using the index, we need not iterate through the hash map. We can quickly retrieve the value. In this way, hash map function is used in retrieving data faster in hash-based data structures. Now let's see what's actually happening under the hood when hash code function is invoked for a string. For any hash function, the basic requirement is it should have minimum possible chance of returning same hash value for two different strings. For example, if we get hash code value of John as 1453, the hash code value of Bob should not be same as hash code value of John. But remember that hash code value of John should always be same each time we invoke the hash code function for the string John. Similarly, the multiple invocation of hash code function for Bob should also return the same value. To achieve these criteria, hash code function will be using this formula. Now let's have a closer look into this formula. Here, n is the total number of characters in the string, s is the string, and s of 0 is the first character of the string, s of 1 is the second character of the string, and it goes on till the last character of the string. Since n is the total number of characters, the last character is s of n minus 1. Actually, a string can be reduced into number just by summing the ASCII value of the characters by using this formula. For example, the string John will be summed by s of 0, which is j, plus s of 1, which is o, plus s of 2, which is h, plus s of 3, which is n. Actually, by summing these characters, you will be summing the ASCII value of each of these characters, which will yield a numerical value of the string. We will get the same value even if we pass a different string just by swapping the position of the letters. Since we have to decrease the chance of getting the same hash value for two different strings, a position relation has been introduced by multiplying each character ASCII value with 31 exponential n minus 1 for the first character and 31 exponential n minus 2 for the second character, and it goes on till the last character. Here we are choosing 31 because the total number of possible alphabets is 26 and the nearest prime number to 26 is 31. In case if our string can have both uppercase and lowercase numbers, then the total possible characters in string is going to be 52. And the nearest possible prime number to 52 is 53. In our example, ASCII value of j is multiplied with 31 exponential n-1, which is 3, and ASCII value of o is multiplied with 31 exponential n-2, which is 2, and the ASCII value of h is multiplied with 31 exponential n-1, which is 1. And finally, ASCII value of n is not multiplied with anything as it is the last character. So this is how hash code is reducing a string into a consistent and almost unique numerical value. If you like this video, please hit subscribe button and bell button. I hope now you got a good understanding on how Java hashcode function is reducing a string to a numerical value. With this, I conclude this video, and let's meet in my next video.